Okay, hi everybody. My name's Mike. I'm from Ottawa Solar Power, as the name gives it away. You know what city I'm from. And my goal, what do I do? My goal is not to tell you how to design a solar electric system, because I guess many of you in this room have probably been involved with off-grid homes in the past, and some of you may design systems. But what I want to do today is talk about how off-grid design has changed because of the equipment changes that have come on the market in the past few years, and how those equipment changes have changed the way you think about off-grid design. I've been doing this for 17 years now, and I'll show the next slide. And I can remember back when we started, solar panel pricing was quite expensive. And what I did was here, I just made up a chart to show what's happened over the years. In the 90s, most solar panels were in that 40 to 50 watt size range. And we were selling them to consumers for around $700 a panel, or that works out to $14 a watt. Then the size of those panels increased to 70 watts per panel. Pricing was in this range, and then we got really excited in about 2000 and I think it was about 2005, 2006. We saw 140 to 180 watt modules come on the market, and we thought we had died and gone to heaven. But they were $10 a watt, so a single panel back then was selling for $1,500. And people were buying them, but it made systems very expensive. So people tried to buy as few of them as possible to keep their system costs down. And then in 2009, the Ontario government announced the microfit program, which came out 2010, 2011. It got rolling, and it started to really drive down the price of panels in Canada. So we started off 200 to 230 watt panels. $600 people were paying for them, around $250 a watt. And then part of that program was you had to use panels that were made in Ontario, which kept the price high. They lost in court, so that rule had to be taken out, and now we could start buying panels from China, which meant 250 watt panels from China, $250 we're selling them for, or $1 a watt. So you can see we went from $14 a watt down to $1 a watt in, I'm going to say, a relatively short period of time. And that really changed the way off-grid design works, because now the panels are not a significant part of the overall system cost. They're still a big part of it, but now you can put in a lot more panels at a lot cheaper price. Recently what's happened, though, is the Ontario manufacturers of solar panels complained to the federal government and the World Trade Organization, saying that China was subsidizing the cost of panels. So now any panels that are made in China coming into Canada are subject to roughly about 150 to 170% tariff. So cheap panels, no more from China. It's driven the cost back up a bit. We're up to about $1.10 a watt, just roughly in that range. That's consumer-based pricing. But still, we've seen tremendous changes in panel costs, which have really made living off-grid a heck of a lot easier now. Back in this day, when we were designing systems, you put in absolutely as few panels as you could, because it was just too expensive. Now you got to think the other way. And just if you go to the next slide, with the low prices, we can do stuff like this now. There's 1,200 panels. This is a FIT project, but that wouldn't have been possible in the 1990s. It couldn't have happened. So this is what's happening in our market. The prices are coming down, and it's just making things easier. The other thing I want to talk about is batteries, which is another big component of the system. Not much is happening on the battery market. You're going to hear about new battery technologies, lithium-ion and sealed lead acids, all changing the way you can look at off-grid, but really the prices of lithium-ion, way too expensive. Sealed lead acid batteries are still very expensive and will be for quite some time. The only thing that might change battery pricing in the future is the electric cars. And the guys from Tesla are getting ready to build a gigawatt battery factory just outside of Las Vegas, I think it is. And their goal is to drive the cost of batteries down so that electric cars can be more affordable. But that's going to spill over into solar because Tesla, the owner of that company, also owns Solar City, which is the largest U.S. installer of solar. And they have a goal of putting battery-based systems into a lot of homes as a backup system and a way of sort of evening out fluctuations in the grid. So his goal is not just for his cars, but also to bring those batteries into the solar industry. So still many years away, but it's coming. The workhorse of most solar electric systems right now are Surette batteries, Canadian company, the L16 size. And in terms of amp hour capacity, these are about 400 amp hour batteries to round it off. And what we've seen is the trend used to be you'd put in a whole bunch of these, or you'd put in a whole bunch of golf cart batteries. The challenge is when you're doing this kind of design, every one of these connections is a failure point, and every one of those connections is a spot where you're going to lose power coming into the battery and coming out of the battery. So the goal is to have as few of these as possible, which means you want larger amp hour capacity batteries. And they're really starting to trickle into the market now. Not at better pricing, but they're just becoming available. The downside is they're very, very heavy, 300, 400, 500 pounds even for some of these batteries. But big battery banks were very common when solar panels were very expensive. Because people said, well, I need a really big bank to get me through 3 or 4 days of no sun. And the reason they wanted 3 or 4 days of autonomy was they didn't have enough solar panels, even on a cloudy day, to help keep those batteries charged. But now, with the price of panels coming down, you can put in more panels and have a smaller battery bank to keep it charged. And I think Frank, he experimented with that not long ago. And Frank, it's made a big difference at your place, right? And you put in an extra how many kilowatts? 1,500 watts. And it dramatically made a difference in your battery bank. Yeah, the wind turbine. Yeah. Go to the next slide. And I'm just jumping from one thing to the other just to give you an overall, and then we'll talk more about where I'm going here. But inverters, the other big part of the systems. Standard inverters at one time, 10 years ago, were 1,500 to 2,000 watt. Usually a modified sine wave inverter, and I think you all know what that means. It's basically just not real clean power. It's kind of like a radio station turned in halfway, and you get a little bit of static. You can still hear the station, but it's not super clear. I refer to that as dirty power. But then they came out with a sine wave inverter, which was clean power. So you're tuned right in, and everything is perfect. And those inverters were selling roughly for about $1 a watt, or $1.20 a watt. Today, sine wave inverters have jumped all the way up to 6,000 watt inverters, and you can get them in a 48 volt system. But they're down to about 78 cents a watt. So a pretty good drop in price. But the biggest change in inverters is their battery chargers that are built into the inverter. Because you can't live off-grid without a battery charger. You still need to be able to charge those batteries, because it's going to happen. We're going to have very, very cloudy days, and the solar's not going to do much. So your generator will be running, producing AC power, going into the inverter, and its onboard battery charger will then recharge the batteries. What you really need on a big battery bank, though, is a lot of current going into it. And this is one of the biggest mistakes people make with battery banks. They go too big. And it's not just my opinion, but companies like Surette Battery, who manufacture the batteries, they want you to have at least 10% of the battery bank's amp hour capacity in charging power. So if you've got a 1,000 amp hour battery bank, you need a minimum of 100 amps going into that battery to properly charge it. And this is the single biggest mistake that people make when they're designing an off-grid system. The battery bank is too big for the amount of solar panels that you have. And I see that all the time.
Does that damage the batteries?
It does. But I'll hear from people say, oh, that's working fine. My batteries are always fully charged. Voltage and current are two totally different things. So you can have voltage come up in your battery bank. I like to use this analogy. I can take a glass and I can pour a can of Coke into it really fast. The glass can be full, but the top half of it is foam. The only part that you drink is the bottom half. The same thing happens with a battery. I can charge it. I can get the voltage up, but that doesn't mean that it's charged. Charged only means if the specific gravity of the battery comes up and it indicates that there's current stored in the battery. But you can't make that happen unless you have enough current going into the battery to overcome the internal resistance. So I often hear from people all the time, no, my batteries are always at 12.7 or 24.7 if they're on a 24-volt system, and they think they're charged, but they're not charged. Just the voltage is up, but there's actually no current in the battery. And what's happening is that's causing the battery to sulfate. So it's lessening the life of that battery bank. So you're not going to go 20 years. Some Surette has batteries that do have a 20-year lifespan. Many people don't make it that far because they don't charge them properly. So one thing that's helping now is battery chargers will have higher current. So when the generator's running, you can get them charged up properly. And the other one is integrated wire management and breakers. So if you just go to the, I think I may have a picture of that. This is what a typical inverter looks like today. You don't see much wiring. You see one wire coming in and one wire coming out. Everything is built into the inverters now. The DC breakers for the solar input, charge controller breakers are built in for the output. Your AC breakers are built into it. Your generator input breakers are built in. Everything is in one package. And if any of you were around back in the old days with off-grid design, you'd have disconnect, 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 disconnect. It'd be just a mess, just a real mess. But now everything is all in one package. So it's much, much cleaner and much, much neater. This thing on the side is actually the charge controller, which is the next biggest change that's happened in off-grid design. If you just go to the next slide. These are also a set of charge controllers here. We're just putting this all into a splitter trough to keep things neat and clean. And the next slide. So this has made the biggest change in off-grid design. Panel prices have come down, but this, in terms of a design point of view, has just changed the game. It used to be if you had a battery bank that was 12 volts, you'd need a 12-volt charge controller. Because the panels typically operated at a voltage that lent itself well to charging 12-volt batteries. Then we went up to 24-volt battery banks, and they came up with charge controllers that could take two panels in series and charge a battery bank. But what's happened now in the market is 250-watt solar panels are the sweet spot for pricing. Like I showed you in the first slide, you can get it down to about $1.10 a watt. The problem is those panels are designed to work with grid-tied systems, the net metering, the microfits, the fit programs. Those panels operate at a much higher voltage. So you can't take a panel that produces 38 volts and put it into a 12-volt battery bank or a 24-volt battery bank. What the new controllers allow us to do is we can wire all these panels in series. So Xantrex has a controller. I can put 10 panels in series. So I'm roughly sending 400 volts to the controller. It's a lot of power. And it takes that voltage and steps it down to 48 volts to charge the battery bank. Now the biggest benefit to this is it's a heck of a lot easier and cheaper to just wire 10 solar panels together in series. It's very simple. But the distances you can run the power have gone up tenfold. So we've done some jobs where we actually have the solar array on a ground mount. The longest run we did was 500 feet from the battery bank, which is amazing. We had to go with a little bit higher wire size, But when the power's coming back in at 460 volts, you can send power a long way because the current was only around 8 amps. So you can send power a long way. So what that's allowing is, the next thing for off-grid design is you don't have to put panels on the roof of the house anymore. And they shouldn't be on the house anyways. I'm very strong on this. They're going to get buried in snow. You're living off-grid. You're relying on your solar panels to make all the power. If they're buried in snow, they ain't making power. And I'll hear people say, oh yeah, but I'll just get up there with a broom and I'll knock it off and, you know, I'll be fine. Yeah, it's good when you're 30, when you're 40. When you're 55, 60, still living in that house at 70, you ain't going up on that ladder to clean snow off a roof. It's simply too dangerous, and you're running the risk of snagging a mid-clip on the panels, breaking the panels. So we at Ottawa Solar Power strongly recommend nobody put their panels on a roof if they're living off-grid. Does it work for some people? Yes, it does. But every site is different. So at Frank's house, he's got them on his barn. Maybe Frank's just in a real good wind tunnel there, and the wind keeps the snow off the panels. But maybe Deirdre over here's got them on her place, but she's not in a wind tunnel, and the snow gets onto her roof, and it never comes off. But you never know what that's going to be like until it's already done. So we recommend ground mount. That way you can easily take the snow off the panels. And is everybody here familiar with the Courtright Center? It's outside of Toronto? Yeah? They've done some extensive testing on this. So they've taken pole mounts and located solar panels on the pole mounts, and they have cameras watching those panels 24 hours a day. And they've also taken roofs and put panels flat on the roofs. And they're watching how long it takes panels that are on a roof at, you know, an 8-12 pitch, how long it takes the snow to slide off those panels versus panels that are on a pole mount with the exact same pitch. And the pole mount sheds the snow 100% faster than the one on the roof, even though they're at the exact same pitch. They don't know why. They think maybe it has something to do with air temperature. I don't know. Jordan, have you ever heard this?
Well, they're doing a bunch of different angles, right?
Yeah.
And I think part of it depends too on like what kind of roof you're on, how much insulation there is there.
Yeah.
Because we've seen some systems on barns and stuff where there's enough heat coming through that helps with it.
Yeah.
But yeah, primarily it's probably just air circulation.
Air circulation to knock it off. Yeah.
Probably keys in between the panel and the roof.
Yeah. So what these charge controllers have allowed now is ground mounts far away, which also gives you the opportunity to put it in a sunny area. Maybe your house, you don't want it in full sun. Maybe your roof gets shaded a bit. Now you can build a ground mount where there's sun, and you can send that power 400 or 500 feet back to the house. It's a little bit more expensive to build a ground mount by, you know, a couple $1,000 bucks. Then you go, that's a few $1,000s. Well, running a generator all winter long is going to cost you 400 or 500 bucks maybe in fuel. Wear and tear on the generator, it's wearing it out. So after about 4 or 5 years, you've more than paid for that ground mount. And then it's pure profit after that. This was a job in progress, but it was so big that we needed 2 of those charge controllers. This was a fairly large home. I think it was close to 3,000 square feet. In-floor radiant heating, security system, every bell and whistle that they could put into the house, they had it there. And I think the next slide shows this is the ground mount that we had to put in for them. So we had 7,500 watts, 30 250 watt panels. That's located, I think this one was about 300 feet from the house. And we keep in good contact with this customer, and they've been running now for 2 years, and his total generator runtime for 2 years is 17 hours in 2 years. It's amazing because it was sized properly with the panels. But when you're only paying $250 for the panel, it makes sense to put in an extra 10 panels. because he's going to burn that up in fuel anyways, or wear and tear on the generator. And it's also going to increase the battery life, because batteries, if they're kept fully charged, don't sulfate as quickly, and they're going to get their 20 years of service out of them. So in the long run, they're going to pay for themselves.
Sorry. And these are, you're saying there's two different kinds of panels, one for feeding the grid and one for off-grid?
Yeah, so the panels that feed the grid, which are these, they're the most readily available panels now in North America, and you can get them in 250, even up to 300 watts. But the standard, the old-fashioned grid or off-grid panels, they max out now at about 140 to 150 watts. But a 150 watt panel, my cost is $380. But I can sell one of these to someone for $250. So the price difference is huge. So there's no need to use the old style panel anymore. Everybody's using this style now. Yeah. Why are people needing larger systems? Well, you're all builders and you see what's going into homes. I think the last 3 off-grid jobs that we did, they all had in-floor heating, which is running all the circulation pumps, so that's taking power. Some of the places are so tight, they need air exchange systems. UV lights for well. You never know if you're going to run into an area that has water that's good enough that's not filtered. So we've got quite a few people that are running UV lights that are on pretty much all the time, and that takes a lot of power. Everybody's got cell phone chargers now, computers, tablets, video games. I've seen it over the past 15 years. People are expecting a little bit better quality of life. They're not willing to live in a cabin anymore or live like it's their cottage. They want the same luxuries that they had at home. So they're using more power. And also reducing generator run times. Yes, the price of gas has dropped recently, but when it was $4.50, $5 a liter, it was costing a lot of money for people to run their generators. So they really want to limit that. A big thing we're seeing now is people are coming to us and saying, I do not want to run a generator. That is my goal. I want to live off the grid, and I don't want to rely on fossil fuels. And the only way to do that is put in more solar panels. Now, the benefits to the larger solar array, increased battery life, because batteries need to be kept charged. They have to be kept charged. If they're not, they're sulfating. If they're sulfating, they're dying. And with bigger solar arrays, you can get away with smaller battery banks. So the trend used to be really big battery banks because you wanted to store as much power as you could. But when that bank is empty, you have to recharge it. It's got to come from somewhere. If you have a small solar array, it can't keep up. It can't keep that big bank charged. So the only other option, run a generator. And we're back to the fossil fuels, the generator runtime, the maintenance, the noise. So now with cheap solar panels, big solar arrays, I can get away with smaller battery banks. Often 50% reduction. So an off-grid home now, usually they're spending $7,000, maybe $8,000 on a battery bank. Well, we can cut that number in 2. So $4,000 savings. It's pretty big, which they can use for more solar panels. More solar panels, as Frank said, on a cloudy day, it's still big enough to probably run all the loads in your house. Even though it's cloudy, you're still running your home. Less system downtime. Back in the old days, a lot of people would run out of power and they'd have to go and crank up the generator and run the generator for the next 24 hours to try to charge the battery banks. You don't need to do that anymore. And like I said, on a cloudy day, you're still charging your battery bank. John, do you find on a cloudy day at your place that you're getting some good charging power? Yeah. And you have 7 kilowatt. How big's your solar array?
6. It's 24 panels.
It's 6 kilowatt solar array. Yeah. Okay. Good.
Now, we've tried the options in Ontario. If I want to run my power tools or do the laundry or the dishwasher, things like that,
Yeah, that's a great point. Yeah, it's free. It's totally free. You're not using up any battery power if you're doing it during the day and it's sunny, because power is just basically flowing in and flowing right out to the loads. So shifting the way you live is key when living off grid. Yeah, you try to do as much as you can during the day when it's sunny. I just want to go through this and then we can chat more, but lower panel prices are allowing for larger arrays. So we talked about that. Larger arrays for smaller battery banks. Larger arrays will result in a fully charged battery bank, which is the key to keeping that asset functioning properly. It'll have more years of life in that battery bank, less generator runtime, less fuel costs, but also a better quality of life.